Hello, I'm Thomas of Geon Technologies, and welcome to the second part of the Property Kinds series covering initialization and resources. As a reminder, at the end of part 1, we had our very simple device that could be reconfigured on the fly with new amplitude and frequency using its control params property. It would then generate a set of samples based on its predefined sample frequency and return a number of them in a sliding window. Now for part 2, we'll be adding the ability to change the number of samples returned in that window, as well as the ability to allocate a preferred sample frequency. We'll briefly sandbox our changes, and then use our waveform to show how usesdevice relationships come into play with allocation properties. This will finish our brief exploration of the lifecycle-related kinds in REDHAWK before we move on to messaging in the next session. Let's start by updating the Sawtooth device. Open the SPD-XML project file and navigate to the Properties tab. Now would be a good time to add default values for control params if you didn't previously. I'm using 10 and 500 from the configuration before. Next, add a simple property whose ID is window. Data type is unsigned short, uShort, with a default value of 100 samples. The kind remains property, but we want pass on the command line and read only. This way, the variable can be set once initially, but not thereafter. This can be helpful for parameters like number of filter tabs. Add the next simple property with ID of sample_freq. Type is float. Default value of 10,000. And set the kind to allocation. This property is the hook for using our signal generator as a resource. Some other entity declares that it needs a signal generator whose sample frequency can be set to some particular value, and if our device can do it, it'll respond affirmatively and be effectively reserved for whatever was asking. In our case, allowing a waveform to find the device and make connections to its components. Save and generate the implementations. Next, open Python implementation file and get the code blocks handy because we're going to make several edits. First is to remove the sample_freq declaration, since now this is a REDHAWK property for us. We'll replace it with allocations_available. The Boolean flag will maintain to determine if something is already allocated us or not. Next, we need to set the callbacks for allocating and deallocating sample freq. Like the property change listener, we'll do this in the constructor method using the setAllocationImpl method. Naturally then, we also need to implement the allocate and deallocate sample freq methods. In the allocate method, we're looking at whether or not the sampling frequency can be supported, and also checking something new, the device's usage state. Busy means that the device is out of allocations that it can respond to. This helps filter out those devices that simply can't respond affirmatively. Failing either of those checks, the allocate call returns false. If the frequency is valid, however, we retain it and clear out our allocations available flag. If we're not already started, we start. For deallocation, it's a similar idea. If we're allocated, we'll be busy, in our case. So we restore our allocations available flag and stop ourselves. Since for this device, if no one is listening, why toil away in a process function? Next, we need to implement that usage state behavior in the updateUsageState method to do exactly this. Busy if allocated once, idle otherwise. It's not supporting having multiple concurrent allocations, so responding active doesn't apply. Then down in the getData method, we can remove our hard-coded count variable in exchange for self.window, our new REDHAWK property. Save these changes. It's time for the sandbox. So open a terminal and from the Sawtooth Devices folder in the REDHAWK workspace, enter the Python shell. We're going to look at this usage state behavior and learn how to allocate properties from the shell. Again, import the sandbox from OzUtils and launch the device. Let's check the usage state using _get_usage S state. Naturally, the device is indicating idle, as expected, since it's waiting to be allocated. So let's do that using the allocate capacity method. Like the configure method in the previous session, allocate capacity takes a map of property ID value pairs for those properties that must all be met for this allocation. However, unlike the configure method, allocate capacity will return a Boolean, true, if all of the property allocations could be met, false otherwise. There's no partial allocation response. Here I've allocated sample freq of 2 MHz. Since the device was idle and that frequency was fine, the device responded true, indicating allocation was successful. Checking that usage state again, it's busy. If we try to allocate again, the device responds false because it was out of capacities to allocate. The deallocate capacity method also takes a map of property ID value pairs. However, with the way that our deallocate capacity method is written, the value isn't going to do any good, so I just pass 0. You can see here that it didn't change the sample frequency value and that the usage state is back to idle. Why even pass a value? Why not just IDs? More commonly, front-end allocations would allocate capacity with a unique allocation ID as one of their properties being allocated. This allows the device component pair to cross-reference one another in case multiple concurrent allocations can occur. Later, the component can deallocate its allocation ID to release the tuner for others to use. To test the window property, we're going to deploy the device in our node and retest everything running from a domain. Drag the sawtooth device to the target SDR so that what the node references is the new version, not the one from the previous session. Open the SigGen node DCD project file. You can see we have a general purpose processor, GPP, for running components, and our sawtooth signal generator device. View its properties by either selecting it and clicking the Properties tab, or, as I'm showing here, select the Devices tab and then the device. Unfortunately, this .0 release of REDHAWK 2.0's IDE has a small bug that prevents you from setting these pass-on command line properties from the node configuration as it should. So we need to do a small XML edit. Find the component instantiation for the sawtooth device 1 down near the bottom of the file. Paste in the component properties and simple ref tags. This will provide an initial value for this property that is baked in when the device is instantiated as the node is launched. Heading back to the devices list, we can see the property value did change to 200. Save the node and close the DCD. Then deploy the node to the target SDR. Now let's open the controller waveforms SAD project file. You'll see it has a usesdevice relationship SigGen connection with a data float out port connected to the data float input port of the data converter. Review the Waveform Basics video to get an overview of how to create and use this. The function of it is to allow the application factory a chance to find an appropriate device by a list of allocations and a specific port ID, or multiple port IDs as we'll see in the next session. For this waveform, we've in essence stated that to launch it, it needs to find a device that has a data float out port on it and a property whose ID is sample_freq that can be set to 10 kHz. And by the diagram, once found, connect that port to the data float port of our component. Close this out and deploy the controller to the target SDR. Right-click on Target SDR and choose Launch Domain. Select the SigGen node as well and click OK. Consoles will be created for both instances of NodeBooter. The domain will automatically be attached to the REDHAWK Explorer view in the right panel. As of this .0 release of REDHAWK 2.0, the Resource Info Service throws an errant warning about it's ignoring your attempt to set the read-only property. That's a warning safely ignored, as we'll soon see. Expand the domain to show the node and select our device. Viewing the properties, we see the window is indeed set to the node specified value and the initial sample freq is 100 kHz. Right-click on the domain and choose Launch Waveform. Select the controller from the list and check the Start the Waveform After Launching option. Click Finish. The green data converter indicates it's started. And if we look at our device in the REDHAWK Explorer, it's also automatically started. Why? Because the used device allocated it and it had capacities available, so it started. Expanding to see its port, the connection is indicated. We right-click and plot the data coming out of one of these ports. data float out shown here, we'll see our sawtooth is humming right along. If we release the waveform, the plot disconnects and closes, the connection to the device is severed, and the allocate capacity is automatically called to release the usesdevice relationship. Looking at the REDHAWK Explorer, we can easily see these changes and that the device has also stopped, which we designed it to do when its only allocation is returned. To shut all this down, right-click on the node and shut it down. We can see in its console that it terminated cleanly, so we can close it using the gray X. For the domain, we have to stop it at its console first and then disconnect or delete it from the REDHAWK Explorer. Just doing the latter steps does not shut down the domain. It only stops monitoring it. So for bonus points, what happens if the node goes down? I've modified our node to remove its GPP to force the waveform to deploy its components somewhere else that has a GPP free. In this case, I'm using the default Dev Manager node. Then launched both nodes into the domain and relaunched the waveform. The waveform's usesdevice relationship still sought out the signal generator and connected it to the component's port. But that component is no longer in our node. See here in the REDHAWK Explorer, the data converter 1 indicates its relationship to localhost domain GPP and our sawtooth device. Trivially, if we shut down Dev Manager, the waveform, of course, gets released because the GPP it's running on shuts down. So we'll skip that test. But non-trivially, what if we shut down the signal generator feeding the waveform? Will the component stay running on that remote GPP? No. The waveform is released because the usesdevice relationship was severed. And that brings us to the end of this session on initialization and resource properties. So let's review. Pass on command line with read-only allows you to bake in simple type property values for initialization of your device or component. Allocation lets you define properties that are resource hooks for other components and waveforms to use. Allocations are checked prior to the waveform or component coming online. And REDHAWK releases waveforms if capacities are lost or removed. Thanks again for watching. This is Thomas with Geon Technologies. Please don't hesitate to contact us for more information or in-class training.